Let's take the next example, next flowchart conversion. We had done that area of a triangle. Let's convert that into C. Now, before we convert it into C, let's understand. Go through this particular flowchart. How many variables we have totally? We have 3. Base, height, area. What are the values for base and height I have given? 9 and 3. What is their data type? An integer. What about area? Area, I am dividing it by 2. So, possibility of what now? A fraction. So, I need to declare this as float. Now, once you finish a program, what you do is close this. Then, open new empty file. Save this file. Let's call this as triangle.c. The first line is #include stdio.h followed by int main, int base, height, float area. Base is equal to 9, height is equal to 3, area equal to, what is the formula? Half into base into height. Let's write that and see. Half into base into height. Printf %f, because area is declared as float and float is format specifier is %f, comma area. What is the next step? I have to save my program again. Now next compile, build, compile, press F2. It is showing 0 errors, no problem. Close this window, go to build and run. What is the answer I should get? 13.5. Let's look at this. Look at the answer. What am I getting? I'm getting 0.000. That means we have gone wrong somewhere. Where did we go wrong? The problem is with this expression. Formula-wise, it is correct mathematically, but it is not according to the rules of a C language. Why? Look at this. How many operands I have? How many operands I have? 5. Area, 1, 2, base, height. Out of that, how many are integers and how many are floats? I have only one float, area, whereas 1, 2, base, height are integers. Let's look at this 1 by 2. First, it will do 1 by 2 calculation. 1 by 2, int by an int. What is the answer? Is an integer. So 1 by 2, I should get 0.5. But what is the integer part of 0.5? It is 0. So 0 into rest of the things will be what? How 0. So this is what we have to focus on. So that means I should convert one of them into a float. How? Say 1.0. Save the program again. When you make changes to a program, you have to save it and again you have to compile. You have to compile when you make the changes. Build, compile. F2, no errors. Next, build, run. Now look at this. I'm getting 13.5. So these are some small things which you have to focus on when you are writing your code. Okay, so this is about the area of a triangle. Now one more thing I want to mention. I said int main over here. Now generally when we say int main, at the end we say what now? Return 0. Why? We will discuss that later. Right now, just give it as return 0. Third example, calculate the voltage using Ohm's law. Let's analyze the flowchart. How many variables we are using totally? 3 variables. What can be their data type? Based on the values I have given, we can make all 3 of them as integer. Let's look at this. Next, new empty file. Save this file. Let's call it as ohms.c. First line, #include stdio.h followed by int main. Int I, r, v, semicolon. I equal to 5, r equal to 3, v is equal to I into r. Be careful, put multiplication symbol. Don't just say IR. It doesn't consider that as multiplication. I into R, printf, %d, v. Save the file again. Go to build, compile, F2, no mistakes, build, run, voltage is 15. Let's look at the next flowchart. Finding the area of a circle. Analyze. How many variables? R and area. Type of R, int, because I gave it as 5. Type of area, 3.142 into R square means I should make it as float. Open. Save. Let's call this as radius dot C. R is equal to 5. Area is equal to 3.142 into R into R. Let's print this. Printf percentage F because area is float and area. Save it. Build, compile, build, run. 78.55000. Now I can write this in another way also. Observe this. Instead of saying 3.142 here, I can give it like this. Const float pi equals, assign it in the same line, 3.142. I cannot put const float pi semicolon and in the next line, I cannot say pi equal to 3.142. Constants should be declared and assigned or initialized in the same line. For other variables, you can do declaration separately and the assign or the initialization separately or in the same line, doesn't matter. But for constants, you should do it in the same line. So now, what is 3.142 called as? Pi. Now you can substitute pi over here instead of 3.142. Save, compile, build, run. The answer is 78.54. Now, this can also be written in another way. I don't want to say R into R. I want to say R square. But we know R square is not available directly. So what you can do is pi into, you can make use of a standard library function called as POW bracket, takes two values, the base and the power. What is base? R. Raised to what? 2. But if I'm using this, at the top, I have to include its header file. So this is hash include. It is available in the header file called as math.h. And since I'm using int main, here I have to say return 0. See, one thing is there, if you want right now, you can ignore this return 0 and ignore the int. You can also just write it as what? Main and like this. This is also okay. So it's up to you which method you want to follow initially. Let's look at this now. Save, build, compile, build, run. 78.54. So this is how we make use of the POW function. Let's look at this printf. I want to print the message hello world. How do we do that? So I will start with printf bracket, put double quotation now because we are printing a message. The message is hello world, semicolon. Save this file, compile and run. I got the message hello world. Next, I want to print the message welcome to C. Okay, so next line I will say printf double quotation welcome to C, semicolon. Save this, compile and run. Yes, I got hello world, welcome to C. But notice how the messages are appearing. I gave it as two printfs, but it is showing it in a single line. Now, I don't want it like this. I want these two lines, these two messages to be in two different lines. So, I want this welcome to C to go to the next line. So, for that, we have to use escape sequence. Now, there are many escape sequences. We are going to now look at something called as \n and \t. \n is to print something in a new line or next line. /t is to print in the same line with a tab space in between. Okay, let's see what do I mean. Now, in the first printf, before closing the double quotation, put /n. It means that the printf that follows /n will go to the next line. Save this, compile and run. Now see the result. Hello world, welcome to C has come in a new line. Now I can put another /n. Now it means it will go to the next line. From there it will give one more empty line and then gives the output. So look at this. One, it came to the next line. From there, another empty line. So it's coming to welcome to C. So this is how you can use /n to print the information in the next line. Now the same thing, let's use /t. So compile and run. So it's printing in the same line. Now you can see there is a space over here. So if you want to print it on the same line with spaces, use /t, otherwise use /n. So this is about your printf. Now I'll give one small flowchart to check whether we have understood the concepts of variables correctly or not. I have given a small flowchart over here with values of ABC 543. I have given some small formulas. I want you to apply the formulas and find out what is the final result of A, B, C, D, E. Remember, I'm not testing your arithmetic skills. I just want to verify whether we have understood the concept of variables correctly or not. Pause the video for a minute, solve it, and then come back and check the result. Let's see what is the result. So this is the RAM location A, B, C given to us initially with 5, 4, 3. The first calculation is D is equal to A plus B plus C. What is A? A in the memory is 5, B is 4, C is 3. So 5 plus 4, 9, 9 plus 3 is equal to 12. So D value in the memory will be taken as 12. So this is D, value is 12. Second step I have given is A equals A plus B. What is A in the memory? 5, B is 4. So this is 9. What is 9? A is 9. So is it a new A that is created or is it the existing A that will be referred? It is the existing A. So that means 5 will be replaced by 9. Third, B equals to B minus 1. What is B? 4 minus 1. B becomes 3. So 4 is gone. In its place, I have 3 now. Step number 4. E equals A plus B plus C plus D. What is A now? Should I take it 9 or should I take it as 5? I have to take it as 9. 9 plus 3 plus 3 plus 12. So 9 plus 3, 12, 12 plus 12, 24, 24 plus 3 is equal to 27. So E value is 27. So what is printed finally as the result? So A is printed as 9, B is 3, C is 3, D is 12, E is 27. So I hope everyone understood this correctly.